This time on Captain Chaos's laboratory, we have the Department 56, geez, Village Accessory City Trolley set of 6. And you can see by the sticky note that was put on the box, trolley will not move. So, I'm assuming the trolley won't move. Let's open the box. Take a look at what we got and see what it's going to take to fix it. So of course we got the paperwork, which talks about how to do your tracking, your tracks, so it can run. Oh, this is probably your warranty card. There we go. So I'm assuming, because I've never seen this before, oh, a nice little U there. This is similar to the Lemax trolley, except it's probably bigger, and Lemax trolley is a straight line, not a U. So I'll put that in the box. It almost looks brand new. The person that owns it puts it away nicely. Now, I don't need all the track. I can just literally stick this on here and see if it moves this distance. If it moves this distance, but it doesn't move on the rest of the track, then we have a connection issue between the tracks. So I'm only going to take out 3 things. Power, track with power, and of course the trolley. And I'm going to take the other pieces of track and move them away. Okay. So the power supply is a 6 volt DC 400 milliamp power supply. This comes with a little notice too. If the trolley hesitates or does not move smoothly, please wipe the tracks and rails. Lint-free cloth. For the best results, use a buffing cloth. That's because if you do anything with trains, because it sends the power down the rails can oxidize or rust or just get coated. And whatever it's coated with, whether it be oils or dirt, grime, dust, it's an insulator. Insulators reduce the amount of electricity, and therefore your trolley and or train may cease to function or function correctly. Alright, now we have it unwrapped. Let's take this off, put that in the box, stretch it out. So, if you don't have this piece, let me give you some close-ups so you can see how it's made. We got a little button here. That's the button that when it hits this plate, it reverses direction. It says Market Square Streetcar. Whew. It's supposed to imitate the electrical wires from above, which is kind of cool. And then there's the bottom. Quality control passed. We got our truck assemblies that are steel wheeled, and these are the drive wheels. These free float or free spin. These don't, so they're connected to the gearbox or motor directly. I am also going to grab a voltmeter, because the first thing I want to test is 1, is this putting out power? 2, is this putting out power? And then 3, we need to open this up. So since the first 2 steps is just checking power, we're going to start there. So let's do that. We're going to set that to DC. And yeah, you can read it there. So, almost 12 volts. That's a lot of free float, which means that we have power. So it's plugged in, power's on. 12 volts. We'll just make sure that should give me a negative 12 volts. So we're getting good power. So we know that power supply and everything's working. I'm sure the owner did it before handing it to me. I'm going to clean the tracks. So power's off. So I'm going to use a little rubbing alcohol. I'm just going to, that way if there's any oils or residue, which you can see here's a little, and then I'm going to clean the trucks. Now, of course, these are a little harder because I don't want to turn. So I'm going to do my best to get inside. Like that. And there's some grime on those too. Now we're going to let the air do its thing real quick and evaporate. The alcohol I use is 99%. Just gonna there's definitely nothing going through it. Hey, I got lights if I do this. So we're definitely getting a connection issue. So now I have lights. Because the inside of the car has lights. So we have a slight connection issue, but the connection issue I don't think is with the track. The connection issue is inside the actual trolley, where it comes up through the wheels or trucks. Alright. Now let's see, how do we get into this? You see we have 4 screws on the bottom. So we're going to start there. If I can find where I put my screwdriver. The videos have been slightly scarce recently, and that's because I've been dealing with, if you didn't watch the one video, there's a death in the family, so I had to leave for a week. And then I am, not that I want to right now, but I am pulling 60+ hour work weeks, and I'm also in the process of, and I have been for a while, it's a slow process, but a full remodel of the house. So some things have to get done in a certain time frame because we are rapidly approaching the season where you don't want to go outside for any reason. It's Arizona, it's just too hot. All right, so we have a circuit board screwed to the lid of this thing. That's where these wires are going up. And these wires are going up, and these are the micro switches that tell it to reverse directions. This actually has a very intricate circuit board for what it is. You can see it down in there. The circuit board, we got the button came off. This, I'll take this button out too so I don't lose it. The circuit board's held in with, looks like 3 screws. I'm going to unscrew it so I can remove this whole housing and not worry about damaging it. And then if you care, there's the inside. And here's our circuit board. Let's do a little examination, make sure we don't find anything that's obvious, like an exploded component or a burn. The last one I did, the circuit board was burnt badly. Not the train car, but just the last circuit board I examined. Capacitor looks good. Capacitor looks good. The diodes don't show any melted or burns. Capacitor looks okay. I don't know why this light's off at an angle though. Why isn't it pointing down like those? I don't see any burnt resistors or diodes. I don't see any black around the tracks. Let's check the back side again for bubbling or I don't want to call them tears because it's not really a tear. It's where the tracks separate. Separations would probably be the best term. Everything looks good. Even the glue, it's starting to yellow here. Probably because it gets hotter here because this is the sound chip. At least it looks like a sound chip. May not be. It's a HA17555. That's a timing chip. Okay. So she looks good. I'll put it back on the tracks. This way we can make sure all three lights work, because I only saw two of them in the windows. Oh, all three work. Okay. And those are old school LEDs based on their color too. Alright, so we have a little tape here which connects the wires to inside. Get that out of my way. Inside here. So I'm going to take off this set of trucks. These are the ones right here, right? Nope, sorry, this set of trucks. These are the ones that aren't moving. These are just picking up power. So you have 2 points of contact to pick up power. You're less likely to have a break in connection if you have multiple points. And I know there's a spring in here. I can feel it. So when I take the trucks out, I might have a spring I have to deal with. No spring. That's weird. And I'm going to feed as much wire as I can, because the motor is encapsulated in here. And how? Right there. So we got 4 screws. 1, 2, 3, and number 4 is behind there. So how do we get this apart? Because the 4 screw is behind the metal. Just trying to take a peek inside. I'm assuming they glued this on. Trying to figure out where I put my needle nose pliers. There they are. Come on. You're trying to move. Yeah, it is glued on. Now, does this wheel come off? Or a truck? It does. Look at that. Now I can get to that 4 screw. get that debris out. And I'm assuming this one's going to come off too, because you can't take the panel off without taking these off. It does. And there's our motor. The motor is an FF-130SH. Also has a secondary part number of BN 413211. And look at all those gears. We got a 14 tooth, a 10 tooth, 14, a 12, a 10, a 12, a 14, a 14, and a 14 with a stepper. That's a lot of gears. Let's see if we can get the motor out. There we go. I don't want to lose all the gears. And there's a big old weight right here, if you can't tell on the camera, which is very common on a lot of trains that are model trains. They help keep the trucks on the track. When I was younger, I used to play with trains all the time. I don't have them anymore, but found that a lot of them are very similar. I guess it also depends on your scale if you're a person that does trains. I did O and HO. I had some N scale. Alright, this motor is covered in grease, and that might be part of the problem. There is grease all over this thing, and that's just like if you remember on any Max videos that have bad motors, you do not want grease in these things at all. I want to check the motor directly, meaning I want to be able to just send power to the motor, but if I hook wires up here and send power to the motor, I could fry the circuit board. It's called backfeeding. But they were nice enough to include this disconnect right here, which they glued together. You know, why wouldn't they? And we can disconnect it, so I could just hook power right up to the motor and see if the motor works without worrying about damaging the circuit board. That was, excuse me, that was very nice of them. Next, I need to get to the contact, so I need to remove the glue that they use as an insulator off the contacts. There we go. I'm going to set this for about 4.5 volts. This motor is probably rated between 4 and 8. And there is nothing happening on this motor. Let's bump her up to the 6. It's not shorted. There we go. The motor's going out. Motor's spinning now. 6 volts is pulling 300 milliamps. But the motor is vibrating. I don't know if the motor gets 6 volts. The 6 volts coming up from the trucks and the freewheel trucks go through the circuit board. It might only send 4.5 volts. So this is 4.5 volts. It's a lot smoother, and it's still got a vibration. It could have just been oxidized from sitting on the internal contacts. If it had brushes, the brushes, I don't know how this motor is built. I'm assuming it has little brushes in there. Oxidization can happen. And with all these gears, you wouldn't be able to rotate the trucks to make it actually break the motor free. So I'm going to turn it off and see if it starts back up. Starts back up. Turn it off. Do it again. Let's check the stall on this. So at 4.5 volts, it stalls at 0.5 amp. Ooh, stuff on the fingers. That's not too bad. The motor is actually working great. I think the vibration is the gear. because when I'm holding it with my finger, I can feel the gear. The gear is it's not a smooth circle. It's kind of wobbly. So let's put it back together real quick. See if it works. And when I say put it back together real quick, I'm referring to plugging it in, like so. Click. Leaving the motor out and just using the track on these trucks. So I thought it had dual pickup. I mentioned that a couple of minutes ago, meaning that both sets of wheels, trucks, send power up to the circuit board. These pick up the power, and then the circuit board does its thing, and then sends it back to this motor. And I'm sure part of the reason it has the extra circuitry is because it has the micro switches front and back to turn the directions, to reverse the polarities. So let's turn her on and see what happens. Motor's spinning. So we got the motor spinning. Now let's see if the micro switches work. So put the That's interesting. It only works in one direction. Doesn't reverse polarity. And then it doesn't respond to either micro switch. Motor might be good, it might just be a bad circuit board. Uh-huh. So we have a problem with the circuitry. It's not reversing the polarity. So what I'm going to do, so I'm not holding the track, is I'm going to hook up my meter or my power supply to the trucks on the front. And then I want to test the power to see if it is reversing and the motor is just not turning backwards, or if also to see what the voltage is in the one direction. So I'm going to see if I can clamp onto anything in here. There we go. There we go. Bump this thing back up to 6 volts. Lights are on. Motor spinning very, very slowly. Pulling 5. Pulling a 1/20 of an amp, but it's spinning real slow, like real quiet. Not like it was when it was on the track. I do need to tip this a little so I can see it. Hopefully you can still see it too. And which polarity are we in? Are we on red positive or black positive? Can't see with my... I think we're in red positive right now. The motor's trying to move because it's on, so let me do that. 2.256 volts. And now it's off. We've got no voltage. Right now it says it's pulling a 1,000th of an amp at 6 volts, and that's because of the LEDs. Turn it off, turn it on. Motor's running. Again, it's really slow. It's probably doing the same thing. Basically 2.25 volts. This micro switch should do nothing, and this one will stop it. Okay. There's a lot of stuff on here to trace. So I'm wondering if one of the transistors is bad or if the brain is bad. But we gotta check. Kind of a bad diode. Where are the micro switches attached? They are both attached to switch 1 and switch 2. Then goes through this diode. This transistor. We got a resistor and a diode over here. Then it continues on the same track to the chip. Let's check one of the others here. Goes there. That's connected here, which goes to this chip. Then where's the next wire go? Got 4 wires. And 2 of them are shared. It looks like the shared wire is this outer track, which should be ground. There's a track that goes all the way around the edge, or negative. So, alright. I was hoping this would have been a relatively easy one to bend this LED up. Because it's stupid. That's why the one window had this bright spot. It's because it's bent down. It's not glowing. It's just got a bright spot. That's why I couldn't see this one. Okay. Well, testing transistors in a circuit board is, well, I don't have any tools for that. My tools all for outside the circuit board. So we'll start with testing the diodes, because there's 1, 2, 3 of the 4, 5, 6, 7, 8, 9, 10, 11. There's 11 of these bad boys. And then we'll test the capacitors too. There's only 3, 4, 6, 8. 1, 2, 3, 4, 5, 6, 7, and 8. Which these are also hooked up to the micro switches, so they must hold some sort of charge, just a small one. Or they could be used for smoothing, because it is a jolt. Yeah, I'm wondering if one of the Zener diodes is bad. There's 2 types of diodes. There's this reddish clear, and these solid black ones on the circuit board. The reddish clears are Zener diodes. They're labeled Z1, Z5, Z4. Can't read these two, but I'm assuming they're Z3 and Z2. Then we have the regular diodes over here, which are the black ones. There's 6. But one of the pieces I was helped diagnosing over the internet turned out that one of the Zener diodes was broke. It wasn't this piece, it was another track driven piece, but it wasn't the track that you assemble. And once they replaced the Zener diode, the whole thing worked. So I'm going to check these. I wish I could read what they actually say on the side, but even with my magnifiers on, it's just not enough magnification. I'll see if I can take a picture with the cell phone and then of course zoom in. That might work using the macro, but it's hard to tell. He said, I don't obviously see anything that's going to tell me what's wrong. One of the components has failed, or multiple components has failed, and it's not switching backwards. So I'm wondering if it was just stuck in the other polarity until I started working on it here, and then that's what reversed the polarity, causing it to start spinning. But it's also only spinning at 2¼ volts. That's why I was saying that this motor can handle the 6 volts. It doesn't mean that's what the circuit board is sending the motor. I'm just going to quickly check the capacitors. So this capacitor is a 10 microfarad. This capacitor is a 10 microfarad, and this capacitor is a God knows what, because they cut off the label. What a bunch of... might tell me on the bottom. 47. So 2 10s and a 47 in the electrolytics. So these two right here. Each one. This one. Well, that's not 47 microfarads. All right, let's check this one over here, which should be right here. .6 microfarads. Let's check this one right. It's under the wires. Of course it is. Right here. Get you out of my way. That one's not good either. I also think it discharged because I could have sworn I saw a small spark. Yeah, this one is not even close to 47 microfarads. It's way off. Let's see, this one's going to be hard to test with the glue. Let me see if I can get some contact. It had contact. Let's try this again. 119 says it's supposed to be 104, so that's pretty close. Should still be within tolerance. one's a little higher, but it's still got capacitance. So let's check this one. And let's check these two. Well, it looks like I have at least one bad capacitor. This big guy right here, which I do not know what it does since it spans 2 tracks. Where's the other track go? Well, one track goes to the chip. The other track's the negative, of course. Oh, that would be my bad. This outer track is not negative. This outer track is positive. So this outer track that goes all around the board is positive. So one side comes from the positive and the negative side goes to the chip. So I have a bad cap. I got to go through and check every component on here. And hopefully, if it's just a capacitor, I can replace that. I'm going to check the diodes and resistors. It's the same process. You just change the setting on your meter if you have a multimeter. And then if I find more components, I'll see if I have some that I can swap out. And you can also look up the part numbers to see what their ratings are, like the diodes, if you can read the numbers. The Zehners are hard because they're so small. That's the problem with Zehners, is they're such a little number. It's hard to see. But these bigger ones, the black ones with the silver bands, are much easier to read. You can look them up online and it'll give you their voltage rating, their forward voltage, their bleed through, so on and so forth, their failure point. Just curious, since this also has a resistor attached to this capacitor, they share. It's probably just a discharge resistor. Let's see what the resistor comes up as. $534 ohms, and it's yeah, no, that one's still good. And there's also a diode on the same capacitor. 0.78 in one direction, and it's open in the other, which is the way it should be. If I remember right, most of the Zehners that I've seen on the animatronics are right around 0.77, 0.78. So I'm going to do some research and see if I can figure out what's going on with this train, or trolley, sorry, trolley board. See why this one keeps it in one direction and this one stops it from moving and sending power to the motor. And we'll go from there. Hopefully I can get this thing repaired for him. It'd be nice to have a trolley that goes back and forth. If I can't, I'm sure there's a circuit out there that'll make this thing go back and forth based on the micro switches. This has no sound, so I don't have to worry about a sound chip, and it's just got basic LEDs, which you can just run from the power with a smoothing capacitor, because every time it goes over the junctions on the train track, it'll probably spike the voltage. So you want something to absorb the voltage to the LEDs so they don't have a problem. But if I can't figure out what's wrong with this board, well, I'll see about trying to find a circuit that uses the micro switches to switch directions. I know of a circuit that would work it will work, but it would work. When I say it would work, is it's a 12-volt circuit, twice the power. The relay that it requires to do it does not work on 6 volts. Technically, you could turn this into a 12-volt system. It's just 2 rails. It's not like you're doing anything else. You just need a bigger resistor and a bigger capacitor for smoothing. But let me see if we can keep this OEM before we do any modifications. Plus, if I have to do a modification, I need to talk to the owner who owns this piece. Just because something can be repaired doesn't mean that people want it repaired outside of the OEM. I've experienced that a few times. And I understand that. If you're a collector of anything, if it's original and broken, it's usually worth more than if it's original and modified. So, you know, it's a trade-off. Somebody could put this on their display. It's original and broken, but if you send it power, the lights come on. So at least you have a lit prop, like it's sitting at the trolley station as an example. And then you don't need to put all the track up. Or you can still put the track up and have it look like it's supposed to work. It's just waiting for people to board. Or you can just have this section of track and have it powered like it's a train cafe, you know, something of that nature. So there's lots of things you can do without modifying the circuit board with a broken piece. Just because it's broken doesn't mean you need to throw it away. But I need to see what I can find first, and then I'll do some research to see if I can find that same flipping circuit or reversing circuit that would work with 6 volts as an example. Because this micro relays that it works with, they don't work with anything below like 8. 9 is about as low as you really want to go, because a 12-volt circuit will work on 9 volts. 8 volts is, yeah, it's pushing it on the low end. Definitely will work on 6. Now, on the other end of that same thing, this AC adapter with the free float, meaning no load, is putting out nearly 12 volts. If the circuit that is designed at 12 volts doesn't draw enough to drop the transformer and the AC adapter down, it may work, because the free float with a transformer circuit, meaning, or not transformer, a relay circuit, a flipping relay circuit, may still work because of the free float. If the free float only drops down to, let's say, 9 volts, it should still work fine. So there's going to be a lot of little testing involved. But again, I need to see what I can find out on the circuit board. I know I have a back capacitor. I need to talk to the owner and see what he wants to do. Then I need to do some research, possibly build the circuit and test it with that power supply that's plugged in over there. Not my power supply, because my power supply will compensate. It'll start bumping up the amperage to compensate for the low voltage. I need to make sure it works with the original power supply, because I'm sure that's what he's going to want to use with it, especially since on the box it's marked. So if you ever decided to sell it or give it away, the person that that gets it would say, oh, 6 volts, and why is there a 12-volt power supply plugged into it, as an example? I mean, you could always scratch this out or paint it or tape it off, but we're going to try and avoid all that. We're going to see what we can do with what we got to make this thing work like it's supposed to. So at the moment, I'm going to pause the video, and depending on what I can find here, what I can do here, and what he says when I let him know, will determine where we go to in the video, whether it's reassembled and put back in this box, or it's repaired because I find that the diode's bad, or other than the capacitor is bad, or it gets modified and hopefully works correctly that way. So at the moment, at 45 minutes, we're going to go ahead and stop this for now, and then I shall return. Okay, we're back with the trolley, and I had a second set of eyes look at it, because I sure I was missing something, and I was. There's nothing wrong with the circuit board, and the one capacitor was good. I just couldn't get a good connection on the contacts. All the components are fine. The other guy, who's part of the RandomJChannel, decided to Google, because I forgot to, this trolley and how it works. I mentioned there's a timing chip in here, and the timing chip is because it pauses for 12 seconds, which means that when it hits the bumper, which is right here, It waits 12 seconds before it goes to the other bumper, which is hooked up right there. The only thing that was wrong with this was the motor was frozen in place from oxidization. That was it. Yeah. And so sometimes getting a second set of eyes to look at something helps. I was telling him what I was working on, and he's like, that doesn't sound right. I'm like, I know. So he took a gander at it. He's like, let's use the good old-fashioned Google. After several minutes, we found somebody who posted a 36-second video of this trolley from a long time ago. Low quality. But the train stopped, and then we timed it for 12 seconds. Then we tried this one, did the same thing. So it's all back together. It's going to hit the bumper right there. You heard it. And then we're going to move it so you can see this bumper. 12 seconds is a long time. And we got to wait another 12 seconds. It's been about 8, 9, 10. So, yeah, there you go. So if you have this trolley and it goes and it's now, and let me preface this before I go. It says in the paperwork that if the train hesitates, check the tracks. It might be dirty, corroded, something's not right. To me, a 12-second delay is a hesitation. It's hesitating. It's not going anywhere. Nowhere on the packaging, the paperwork doesn't say that this thing sits for 12 seconds or any duration. I assumed, and that's on me, this was like the Limax one, that when it hits its stopper, or in the Limax it's a magnet, it reverses and just goes back and forth, back and forth, back and forth. I didn't know that it takes, in 1 minute, it can only go back and forth, depending on how much track you have, 4 times. That's really slow. That would be really nice to be written on the box or the paperwork, but it's not. The other guy looked at it too, and he's like, there's nothing on here. I'm like, I know. So basically, if yours isn't moving, turning on, open, just like this one was originally, take the 4 screws out of the bottom, lower the tray, take the tape off, unscrew the trucks that don't spin freely. See, they're free spinning. These are the ones that are attached to the motor. You're going to have to pop off the guard with the screws, the side with the screws. Pull off this truck and this truck. They slide off. Then take out the 4 screws, pull it out, and there's access to your motor. If you spin it and it starts working, it means it's oxidized in place, which means the contact has a layer of corrosion built up between the 2 contacts, which means there's no electricity flowing. A lot of times, just by running the motor, it cleans it right out. As you saw, it's working just fine. And I've had it going back and forth in this track. Actually, I just did it with these 2 together. I wanted a longer track so you could see it better. I think we've done it about 20 or 30 times before we turn the camera back on. So, but once you get it going, you can put it back together and test it. Or just set the circuit board on top and test it without the body. Now, if the motor is bad, or any of those gears are bad, you can get replacement motors. There's one. And I wouldn't get the one that's rated like 6 to 9 volts, since this is only sending 2.5 to that motor. I would get one that's rated 3 volts, which this is a 3 volt hobby motor. It's rated 3 to 4.5. So this motor, as an example, would be the replacement for here because it's 3 volts. It'll still spin at 2.5, but a 6 volt motor won't spin at 2.5. And this is a 6 volt input, but only 2.5 approximately to the motor. And that's it. Because at 6 volts, this thing would be screaming. It hit that bumper so hard, it'd probably separate your track. So, but outside of that, the gears, you can get them in the standard gear kits you get from either Amazon or Skull Crane. I can link them below. They're just a combination of 10, 12, 14, and 16 teeth gears, which the thing about the Skull Crane kit, which I have right here, is they label the teeth on each of the compartments. Apparently this one doesn't want to stay open. And right there. So this doesn't have the 12, but it has the majority of your gears just in this small kit. You can get a bigger kit from them too, but I'll link them below just in case you open yours up and you got a cracked gear or a gear that's missing teeth or slipping. Since the gear that's pressed to the motor and the gear that's pressed to the axle is actually not supposed to slip. The rest of them are supposed to slip. They slip on the shaft. So other than that, not too horrible to disassemble. Very basic. About a dozen screws total. If you are going to take it all apart, you don't have to take the circuit board out. You can if you want. I did straighten the one LED so it's pointing down. And other than that, everything else is just testing the components, which I spent about 30 minutes doing that. And then I got a second set of eyes because I knew I was missing something. I just couldn't see what I was missing. And what I was missing was not researching the piece to see exactly what it does, meaning that it has a delay. So I usually try to look up the pieces ahead of time, but I made an assumption that this should just go bounce, go, bounce, go, bounce, go, not bounce, stop, wait, and then go. I should have figured that out when I saw the timing circuit. The 555 chip that's in there, it's a timing circuit. Timing circuits most of these pieces are generally used for lights. It times the light patterns. These lights don't flash. The timing circuit is that when it gets the signal from the micro switch, it starts counting to 12. 12 seconds. Then it goes. And it goes back. Then it goes. Then it goes back. With a 12-second delay at each stop. So I wish it was on the instructions. It would have saved a little bit of time, and this video wouldn't be pushing an hour if the instructions would have said that there's a 12-second delay. The video would have been 20 minutes, not 60. But this is how we learn. Everybody makes mistakes, and at least it works. And I can put it all back in its plastic, put it back in its foam, stick it back in the box, and get it back to its owner, saying you just had an oxidized motor, and it's good to go. So, until the next one, thanks for watching. Hopefully it won't be something like this where there's no paperwork that says there's a delay, and there'll be less of an issue. But other than that, it's fully functional, all set, fully assembled. Trucks are on. Glued the guard back on, as you can see. That one that I popped off, because there's the screws. There's the screws. Everything's good to go. So she is set to go back to her owner. So until the next one, thanks for watching.